Hello, everyone, and welcome to the webinar Finfish Aquaculture 101 for Coral Reef Managers. This webinar is co-sponsored by the Nature Conservancy's Micronesia Program, Global Aquaculture Program, and the Reef Resilience Network. Thank you for joining us today. My name is Sherry Wagner, and I'm the Reef Resilience Network Coordinator and the host for today's webinar. Before we begin, I'd like to go over a few housekeeping items. Today's webinar will be an hour and a half. It's being recorded, and the recording will be sent out to our mailing list after the webinar and also posted on our website. And there will be a Q&A session at the end of the presentations. So today we're lucky to have a number of aquaculture experts with us. We have Robert Jones. He's the Global Aquaculture Strategy Lead at the Nature Conservancy. Julio Camperio is a PhD student in aquaculture at the University of Miami. Jonathan McKay is a marine spatial scientist at the Nature Conservancy. Stephen Victor is the Micronesia Program Director at the Nature Conservancy. And Tiffany Waters is a Global Aquaculture Manager at the Nature Conservancy, and she'll be facilitating our question and answer session today. So a big welcome to all of our presenters. There are two ways you can ask questions during the question and answer session. You can use the question box anytime throughout the webinar to send questions, and we'll keep track of them for the end of the presentations. Or you can raise your hand during the question and answer session, and we'll call on you to ask your question during that time. You raise your hand by clicking on the small hand icon on your toolbar. And if you're having technical difficulties such as trouble hearing or seeing the slides, please type a message in the question box and we'll try to help you resolve the issue. So we're very excited on this webinar to share a new resource that was just launched, the Aquaculture Toolkit on the Reef Resilience Network website. The toolkit is designed for marine managers and practitioners who already have aquaculture in their area or are planning for it. And here's a screenshot with the URL at the top. So the toolkit contains information and resources on the global status of finfish aquaculture, including species, what species are being produced, and the trends of this growing sector in tropical reef areas, farming and culture methods, impacts on wild stocks, habitats, water quality, and fish health, and what can be done to mitigate these impacts, legal and regulatory frameworks to support sustainable development, environmental impact assessments for operations, site selection and area management approaches, and community-based aquaculture and the role of stakeholder participation and planning with a case study from Palau. And you're going to hear much more about these topics today on the webinar. But before we go any further, we want to learn a bit about who's joined today. So we have 3 poll questions for you. I'll just go ahead and launch. The first poll is, how familiar are you with finfish aquaculture? Not at all, somewhat familiar, or very familiar. So this will give our presenters today an idea about how much you guys know about aquaculture. Okay, looks like most people have voted, so let me share the results. So it looks like we kind of have about even, somewhat, and very, and some people not at all. So a little bit of a spread, like across the board. They're pretty close. So let me share the next poll with you. We're interested to find out where everyone is joining from today and where you work. So go ahead and let us know which area is closest to where you work, or if you work in multiple ocean basins, you can click there. Okay, So let me close this one and I'll share the results with you. Okay, so it looks like mostly Caribbean, Atlantic, some Pacific, and this is reflective a little bit of the time zone, and we have some other. Great. Okay, so one more question, just about your role. Are you a marine resource manager, a practitioner of aquaculture, or aquaculturist, scientist, researcher, student, or none of these roles really fit what you do? You can choose other. Okay, so let me share the results. It looks like we have a lot of scientists, researchers, other, and then marine resource managers, and very few aquaculture practitioners. Great. So welcome everyone, and thanks a lot for taking the poll. Let me just hide this. Okay. All right, so with that, I would like to turn it over to Robert Jones. He's the global lead for the Nature Conservancy's aquaculture program. The program consists of active projects in 7 countries designed to ensure aquaculture operates in harmony with nature and provides benefits to people. So go ahead, Robert, and
Great.
I'll turn it over to you.
Well, thank you, Sherry. Good evening and good morning to some of you. And thanks for joining us for the launch of the Reef Resilience Network's Aquaculture Toolkit and our 101 on Finfish Aquaculture. This is a collaboration between the Reef Resilience Network and TNC's Global Aquaculture Program and TNC's Marine Aquaculture Program. Aquaculture is a really important topic, and it's critical to get it right for the health of our ocean and the people that rely upon it. The stakes are extremely high, and so could be the benefits. It's an area that each of you as reef managers and scientists will have a big role in determining whether aquaculture will be a force for good or conversely result in negative impacts on marine ecosystems. Aquaculture is growing extremely rapidly around the world. As many of you know, at about 6% per year, it's the fastest growing form of food production, and it's larger today overall than wild fisheries or the beef sectors. And at TNC, we view this growth as both an opportunity from an environmental and social perspective, but also a significant challenge. It's an opportunity because aquaculture can actually be one of the best sources of animal protein production we have from a resource utilization perspective. To produce a pound of fish through marine aquaculture or finfish aquaculture, it results in 1/10 of the greenhouse gas emissions compared to beef. In the case of oyster aquaculture, it takes about 1/100th of the greenhouse gas emissions compared to beef production on a per unit basis. This is really important given that food production accounts for 25% of greenhouse gas emissions today. And it also accounts for 70% of habitat loss and 80% of freshwater usage. Aquaculture also shows similar efficiency compared to terrestrial animal agriculture in water and land usage. Fish in the sea, due to climate change and overfishing, are also getting less reliable to harvest. Aquaculture can play a key role in building resiliency in communities and creating long-term jobs as an alternative to wild fisheries. And of course, seafood is also good for us. It's a key source of protein, omega-3s, and other essential nutrients that are rare in other foods. Seafood's a critical part of our diet in the developed and developing world alike. Next slide. And in some cases, such as with bivalves and seaweed, it's even possible that aquaculture can provide benefits back to the environment through nutrient mitigation and habitat provisioning services. This is a really exciting opportunity to improve the health of the ocean while helping us reach food demand needs. Next slide. Aquaculture can also be a source of gender empowerment for communities, such as these seaweed farmers in Tanzania. Women today represent over 70% of the world's aquaculture workforce. Next slide. But in spite of these opportunities, there are big challenges associated with aquaculture, and they've mostly had to do with the finfish aquaculture sector, which is the main topic of discussion today. Some of the impacts that we'll get into detail on will include water pollution impacts. Aquaculture has contributed to eutrophic waters around the world. We now have about 500 dead zones around the world, and we need to reverse that trend. We don't need more contributions from aquaculture. Habitat degradation in some places in the world, such as Southeast Asia, aquaculture has accounted for 30% of mangrove degradation due to the development of aquaculture ponds. Impacts on wild stocks, both in terms of genetic and feed impacts, can reduce genetic fitness of wild fisheries and put pressure on vulnerable fisheries resources. And finally, disease can result in transmission within the farm and also possibly outside the farm, posing a threat to wildlife. This is a picture from Hainan, China, where I was able to visit a few years ago and actually see this in person. It was quite impactful on me. And these big four impacts of aquaculture, which I have described, have too often been the case as aquaculture has developed around the world. So it's on us to make sure that we put an end to these impacts, and aquaculture can really live up to the environmental and social promise we think it has. We also must be keenly aware that aquaculture in tropical areas where coral reefs do exist must be subject to particular care given the sensitivity and immense stress already put on these ocean treasures. So that's why I think our discussion today here is so critical. The module we've developed in our discussion today is about how we can ensure mistakes of the past are not made and the industry can be managed in a sustainable and responsible way. With that, it's my pleasure to introduce our panel. Julio Campario is currently carrying out his PhD in aquaculture at University of Miami Residencial School of Marine and Atmospheric Sciences. He was previously working with the Nature Conservancy in 2019 to travel to Palau, Micronesia, and carry out nutrition research on locally farmed rabbitfish. Jonathan McCoy is a marine spatial scientist at CSS under contract with TNC and is currently working under a NASA-funded project in Palau to address food security by building local capacity around siting and planning sustainable aquaculture. He holds an MS in environmental science from California State University, Los Angeles, and a BS in marine science from University of South Pacific, Fiji. Stephen Victor is TNC Micronesia's TNC's Micronesia program is going to be discussing a case study in Palau and its efforts to develop sustainable aquaculture. Stephen's a native of Palau. He received his MS in biology in 2002 and his BA from University of Guam. Stephen was a researcher at the Palau International Coral Reef Center from 2002 to 2009. In 2009, Stephen joined the Conservancy as a conservation planner, and since January 2016 has served as the director of the Micronesia program. Stephen's been taking a leading role in TNC Micronesia's program in community-based fisheries management and the development of alternative livelihoods such as aquaculture. So thank you all very much, and I will pass it over to Julio.
Okay. Hello, everyone. My name is Julio Camperio, and thank you, Robert, for the introduction. Today, I'll be focusing mainly on the environmental impacts of marine finfish aquaculture and different mitigation strategies that can be carried out to minimize those impacts. So next slide. So aquaculture is generally defined as the culture of marine organisms in a confined and controlled environment. Those marine organisms can either be in the form of finfish, as we can see in this image with the rabbitfish. It can be shellfish and crustaceans, or micro and macro algae. And the confined and controlled environment part of aquaculture can either be earthed ponds, inland, of course. It can be coastal net pens or coastal cages, or as more commercially advanced, it can be open ocean cages, traditionally used for salmon farming. As you heard earlier, the toolkit of today's talk will mainly focus on finfish aquaculture in marine coastal environments. Next slide. So as we mentioned multiple times already, aquaculture can have potentially negative impacts on the environment if certain protocols and management strategies are not properly carried out. And as Robert mentioned earlier, some of those impacts can be impacts to wild stocks, impacts to the local marine environment, general water pollution, and diseases and parasites that can be sourced from the farm. Now, it's very important to keep in mind that all sources of protein production can have detrimental impacts on the environment. And the best way to minimize those impacts is to carry out proper planning, correct management, and appropriate mitigation strategies before any of these impacts get too out of control to mitigate. Next slide, please. So impacts to wild stock can come in mainly 4 different categories. It can be in the form of removing wild species to use as fry in the net pens. It can be in the form of fish escapes if the net containing the fish breaks. Entanglement of wild species, especially marine mammals and sea turtles and seabirds, can occur. And there can be detrimental effects from feed if proper feed quality and proper feeding amounts are not rigorously followed throughout the operation of the farm. So next slide, please. So generally, aquaculture relies on a steady supply of fingerlings or fry to be stocked in these cages, in these net pens. And it is ideal and highly recommended to try and source those fries from local hatcheries. If there is no hatchery available, then it's possible that over time, too many young fish will be removed from the wild, and that will impact the wild population because it will reduce their reproductive capability. And if there's no hatchery available and you have to remove wild fingerlings or fry from the ocean, try your best to not farm fish that are currently overfished, because if you're just removing more and more fish from the ocean of a stock that is overfished, then you're reducing even more of those numbers. In terms of the escapements of fish, it is very important to carry out regular gear monitoring and maintenance. When a feed operator accesses the cage or the net pen to carry out daily feedings, it's very important to take a look at the net and make sure there's no holes or rips. In these situations, it's better to be proactive than reactive. Another option is to farm local species. So in case if there is an escapement, you're not introducing an invasive species into the local environment. And as I just mentioned earlier, it's better to be proactive and fix a gear that needs repair rather than fix a net that already has a hole in it. In terms of entanglement of wild species, specifically about protected marine mammals and sea turtles and seabirds, try your best to site the cages away from areas that are known to be frequented by these animals. Some of these species are migratory and they follow specific routes. So it is ideal and recommended to site these cages away from these areas. And at the same time, try and monitor the movement and patterns of these animals to see if they're getting too close to a cage. In terms of feed, the impacts of feed, it's important to understand that feed is one of the most expensive components in terms of operating the cages. So it's very important to mainly make sure you're using commercial pellets rather than whole fish trimmings, or animal slaughter waste to feed the animals, as introducing these biologic materials can really deteriorate the water quality within the cage and in the surrounding environment. And it's very important to not overfeed the fish in the cages. This happens a lot of times, that the fish are satiated and they're not more hungry, and the farm operator keeps feeding, causing too much feed to either sink to the bottom of the cage or float away. And that is just unnecessary amount of nutrients that is being added to the marine environment, that especially if it sinks, it can accumulate and cause dead zones of oxygen, which are areas deprived of oxygen, and that can have serious detrimental effects. So it's very important to choose good quality feed, but also feed the fish the right amount and do not overfeed. Next slide, please. The second impact is impact to habitat, mainly looking at sensitive habitats. Some of those habitats can be coral reefs, seagrass beds, mangroves, coastal nurseries and spawning grounds. When a site is being proposed, it's very important to keep these sensitive habitats in mind. Gear loss can also impact the local marine ecosystem, both with migratory species, but also if you have gear that is floating around, it can potentially damage local vessels. And reduction of water quality is another big one, as Robert mentioned, especially in areas that have too many farms that are not properly managed. There can be detrimental effects in the water quality and eutrophication. Next slide. Okay. So as I mentioned, some of the more sensitive habitats that we're trying to protect are coral reefs, seagrass beds, mangroves, nurseries, and spawning grounds. That's why it's very important to assess the available areas in the area and choose an area that is far away from these sensitive habitats. General rule of thumb is you need a distance of 200 meters from coral reefs, but that can change depending on in what country and region you're trying to farm. So each regulatory body will have their different minimum distance, but the further away you are from these sensitive habitats, the better. Account for vertical and horizontal distance from these sensitive habitats. Don't consider only the horizontal distance, but consider also the depth. You don't want to set up a farm or a cage that is directly above a coral reef or seagrass bed. And at the same time, you also want to account for current velocity and direction, because the current will either bring these nutrients and fish waste either further in towards the coast if there's an incoming tide. And if there is an incoming tide, then you're just bringing that excess nutrients into potentially sensitive habitats. So site selection and choosing the appropriate area is very important. Damaging of gear, which can affect the local habitat, can be mitigated through regular monitoring. If you see some gear that is in the process of deteriorating, try and replace it before it actually breaks off from your system. And for a reduction in water quality, it's recommended to carry out an environmental impact assessment of the proposed site, which basically takes into account the environmental parameters of that site, and it determines if the production you plan for will have a negative effect on the environment. So it's very important to try and assess this overall ecosystem balance to see if your production will have a negative effect or not. And the last point is to monitor the local water quality. Ideally, you want to have some water quality parameters before you start the production and even before the construction of the cage or of the net pen, so you have a baseline of water quality. That can be temperature, oxygen, pH, ammonia, nitrites, nitrates, chlorophyll, and all sorts of other parameters. So once the production begins in the finfish, you can see which of these parameters are being affected. So then you can take appropriate mitigation strategies. Next slide, please. The third impact that finfish aquaculture can have is general impact on water quality, which can cause water pollution. A big factor in this is the addition of excess feed in the environment and overall waste produced by the fish. Environmental parameters can be impacted negatively, as I mentioned earlier. And something to keep in mind is carrying capacity. And the general idea of carrying capacity is the amount of fish weight that a specific environment can sustainably sustain. Each environment, depending on different parameters that can be current, depth, temperature, tides, and other factors, each environment will have a different carrying capacity. So you don't want to go over that carrying capacity, because then the environment will not be able to sequester the excess nutrients in the form of nitrogen and phosphorus, and that can have a trickle effect and cause a whole bunch of negative impacts on the environment. Next slide, please. Okay, so as I think I already mentioned a couple of times, it is very important to avoid overfeeding the fish and try and use commercial pellets. As I mentioned, pellets, if they sink, they will sink at the bottom and accumulate, and over time, they can cause a dead zone and completely make the area under the cage barren, and the overall diversity and density of marine animals in the benthic area will be negatively impacted. Site the cages in areas that have enough depth and distance from sensitive areas. A general recommendation is that the depth of the sea floor should be at least twice the depth of the cage. And obviously, something to keep in mind, as I mentioned earlier, is current. You don't want the current to be constantly flowing towards a coral reef or a mangrove, because then that sensitive habitat will just be overloaded with potentially an excess of fish waste. As I mentioned, determine the current velocity and direction, especially if you have incoming and outgoing tides. That's something you can, because if it's going incoming, it's going to more flow closer towards the coast and potentially even populated areas. But if it's flowing out in the open ocean, then you have more volume of water that can assimilate and sequester those nutrients. And as in many of these points, regular monitoring of water quality before and during production is very important, so you can see how your production is affecting the water quality in the area. And another recommendation is try to take water quality parameters at different areas within the farm, downstream, upstream, within the cage at different depths, so you can start understanding the overall water quality of the area. In terms of the excess carrying capacity, it is ideal to carry out and determine the carrying capacity limit. These can be complex models, but there is a general idea that the higher density of fish you're farming, the less growth you require. So if you give fish in a confined space more space and more volume to swim around, they will be happier and they will grow quicker than if space is limited. Do not overstock an ecosystem that will not be able to sustain the nutrient accumulation. Every ecosystem has the ability to absorb a certain amount of nutrients. If that limit is surpassed, then there can be detrimental effects. It's very important to try and stay below that level. And as I mentioned earlier, proper planning during the site and cage selection is very important. Different cages, depending on the species you're selecting, there are recommended cages, but planning and selecting the right site for the farm is incredibly important in the overall success of the productivity, but also to keep the environment healthy. Next slide, please. Diseases in farm fish is a complex topic because there are various factors that can cause an outbreak of a disease. And diseases do greatly impact the productivity of the farm. If your fish are sick, they will eat less, they will grow less. You can have mortality, which means you will have a smaller harvest at the end of the season. Your harvest period might be extended because the fish are growing less. But at the same time, if you have mortality within the cage, you're also harvesting less fish, and so you have a smaller profit. So it's very important to try and control internal factors as much as possible. And you can see this in this diagram. External factors are generally hard to control because it's kind of up to the environment. But the internal factors on the right are factors that the farm operator and the manager can manage, and they can try and control them as much as possible to have the fish healthy. If the fish are healthy, they will grow quickly and you can sell your fish at a sooner point rather than having a delayed harvest. And just like overall maintenance and observation of the cage, it's very important to be proactive and not reactive in case of disease. You want to try and catch a disease before it occurs rather than waiting until you see a whole bunch of your fish sick to then start acting. And in fact, it's more economical and more environmentally friendly, I would say, to try and be proactive rather than reactive. Next slide, please. So one of the impacts that can cause a disease is biofouling, which is the growth of marine material on the nets of the cage. It's basically in the form of algae growing around the ropes of the nets. And what happens when you have too much biofouling, you're actually limiting the amount of water flow going through the cage. If you're reducing that water flow, you're also reducing the concentration or oxygen-rich water going through the cage and being absorbed by the fish. So if you have reduced water flow, you're also having reduced water quality, and that can stress out the fish. And stressed out fish are more likely to be impacted by parasites, which then can lead to diseases. So this is very important to regularly clean the nets when the cages are empty. You can either do so by going in the water and brushing the nets. You can remove the nets and bring them on land and scrub them down. But it's very important to try and remove as much of this marine growth as possible, because parasites love to burrow into this marine growth. And so once the parasite cyst develops into larvae, it will hatch from the nets and then attack the fish. So the least biofouling you have on the cages, the happier your fish will be in the long run. To reduce the diseases and parasites, it is ideal to maintain a reduced stocking density. Stocking density is the amount of fish you have in a specific volume. And as I mentioned earlier, there's a general idea that if you have too many fish in a cage, growth will be reduced. While if you have more fish in a cage, then the fish will grow faster and happier. A recommendation is to not install cages too close to each other. And I think if you recall from the picture Robert showed us, there's hundreds of cages one next to each other. And that is not ideal, because if you have one cage that gets sick and the current is moving downstream, then you might be transferring that disease or that parasite downstream to all the other cages. So it's good to have the cages spread out. Another thing to keep in mind is when you're feeding the fish or you're monitoring on the daily routine is to observe physical changes and physical and behavioral changes of the fish. These two changes are very important into determining whether the fish are sick or not. If they're feeding less, if they're usually schooling fish, but you see them not schooling, if they're at the bottom of the cage, if they're rubbing their sides on the net, that's a general indication that there's a parasite. If their fins are rotting, if their eyes are popping out, if they have lesions on their skin, these are all indications that there's something wrong with the fish, and appropriate mitigation strategies need to be carried out to prevent fish mortality. And the final point is the nutritional perspective of the fish. As I mentioned multiple times, it's ideal to feed commercial pellets to farm fish, specifically because now they are producing commercial pellets that are specific for different species of fish, which these feeds meet the nutritional requirements of these fish in terms of protein, lipid, carbs, and energy. These feeds are formulated for specific fish, so that when the fish eat this pellet, they are acquiring all the nutrients they need to grow in a healthy way. So that is one big recommendation to try and reduce diseases, is to use a good quality feed. Next slide, please. So as a final take-home message, first of all, it's important to understand that all these impacts are somewhat interrelated, and these impacts can be minimized if planning before any construction takes place. It's important to choose your site appropriately, choose your cage appropriately, an environment that will have minimal impacts. Locate potential errors through site selection. Is there keeping in mind currents, the velocity and the direction, the depth of the cage, the kind of seafloor you're working with, and whether there are any sensitive habitats in the areas is very important. Try your best to get access to environmental data before you begin any construction. So you can see, once you're producing a specific kind of finfish, to see if you are having any negative impact in water quality, because then you can compare your present data to past data that you collected. And the fish need to be fed every single day. So there is going to be someone on the farm every single day, and it's their duty to observe the fish, their health, and see if they're behaving in a strange way or if they're eating enough, because that is very important to determine if there's any parasites and diseases, and then you can take appropriate actions. So my presentation is done, and I will pass on the virtual microphone to Jonathan. And thank you for your time, everybody.
So I'm going to be presenting on marine spatial planning, or siting. You can go to the next slide. So in this slide here, we have an infographic that helps explain spatial planning or siting. And siting is the first and most important step in aquaculture planning. And what does good siting mean? Well, for us, it means locating a farm that doesn't impact the environment, works with the community, and for the business as well. And when we look at this infographic, we can see that there's different factors or different areas that we would want to avoid when planning aquaculture. And starting at the top of this image, that round circle is just an aerial overview of the area. So we can see in green, these are areas that we would want to site aquaculture, avoiding these areas that are in orange. And these orange areas, in this case, it might be important fishing areas, could be a coral reef, a nearby coral reef. And then close to shore, it could be a mangrove or a seagrass bed. So those are areas that we want to avoid. But for the business, we also want to make sure that there's a port nearby. You want to make sure that there's the facilities that would sustain the aquaculture in the area. And when we say smart siting or aquaculture siting, it's really the process of finding ocean space for aquaculture farms that doesn't conflict with other ocean users. Avoid the areas that contain sensitive habitat, such as, like I mentioned, coral reefs, mangrove areas, seagrass beds. And you can go to the next slide. And with this, we also have 20 key factors when planning a farm. We have 20 here. You can go to the next slide. And I'll go into detail in a few of those. But there's three main areas that these factors cover. It's environmental, social, cultural factors, and operations and logistics. So starting with the environmental factors, as Julio mentioned, depth plays an important part in fish health. It also plays an important part when we talk about siting. So we want to site a farm where there's deep enough water, that there's strong enough currents to flush any excess nutrients. It's good for fish health, but it's also good for the environment in general. So we recommend a depth between 20 and 60 meters. And then we also want to think about the water quality, temperature, and salinity in the area. Has the water quality been tested? Is there enough dissolved oxygen for the fish? Do we have measurements on that? What are the temperature ranges? And these are data that we can use to help site a farm. Next slide, please. So when we talk about political, regulatory, and social cultural factors, we want to make sure that there's avoidance of other uses in the area. This could be things like tourism. It could be a resort nearby you may want to avoid. And we also want to be careful about important fishing areas. And that's where a lot of the local knowledge comes in for these siting analysis. So we want to make sure we avoid those areas and reduce those use conflicts. Is there an important dive site nearby? So those are some of the factors that you want to think about when planning aquaculture, especially when you're thinking about social and cultural factors. Next slide, please. So looking at the operational and logistics, we want to think about things like costs. Is there fingerlings, is there small fry available near this location, or will they have to be brought in from far away? Is there local capacity to grow these fish onshore before they're put out in cages to grow? Is there the availability of feeds nearby? How far from shore is this location? Are you going to be using a lot of fuel to get out to this site, to monitor it, to harvest fish? Is there a hatchery on shore that can support that industry? So these are some other factors that you need to think about. All up, we have 20 different factors through this toolkit that you can access and read more about each one on those three main categories of environmental, social and cultural, and operations and logistics. So next, I want to tell you more about a project in Palau. If you go to the next slide. So there's a good example of some siting that we're doing in the Republic of Palau. It's a project led by TNC in partnership with the government of Palau. And it comes through a NASA grant to identify areas that are suitable for aquaculture development. And the project aims to site or locate aquaculture sustainably to help improve food security while preserving Palau's pristine marine environment. And what we have on the screen right now is just a pretty basic layout of how we run one of these spatial analyses. And this is a computer exercise that we do. We feed in data. And as you can see in this, we have two different data types, vector and raster data. So your raster data could be things like satellite imagery. You could have sea surface temperature. You could have a bathymetry layer that was derived from satellite images. And then we have vector data, things like important channels for boats. You could put in that data. You might have important areas for specific species, like there's a turtle nesting beach, or there's a dugong area where sensitive habitats are, like coral reefs. So we feed in data, and the model produces a suitability score, where 1 is the highest and the most suitable for aquaculture, and 0 would be incompatible with aquaculture. So once we feed in all that data, we get results for the suitability model. And if you go to the next slide, I have an example of some of the results. So this is for Republic of Palau. We're looking at finfish. And where you see the greenest areas, these are the most suitable for finfish development. And if you go to the next slide, this is a zoom in of the area. And you can see pretty clearly here that the areas that are green are avoiding, we have a marine, a vessel channel that runs through here. So you're gonna have a lot of boats going through there. So you can see that there's a gap there. It also avoids a lot of the coral reefs. It's far enough from shore and deep enough water for finfish aquaculture. And these are just some examples of the results that we have. If you want to explore them further, you can go to the maps.coastalresilience.org/Palau. We have a live web tool with preliminary results that we'll be updating later this year as we progress through this siting project in Palau. Thanks for the opportunity to talk, and I'll turn it over to Stephen.
Hello, everyone. My name is Steven Victor. I'm from Palau. For the last 5 years, I've been leading the Sustainable Aquaculture Development Project for the Nature Conservancy here in Palau and across Micronesia. And our goal is really, there are really two goals that we're using aquaculture to try and address. One is development of sustainable livelihoods for local communities, as well as addressing healthy protein source, which I'll talk about why it's important to focus on fish within the presentation. Next slide, please. So here you see a map of Palau for those who do not know where we're situated. We're just north of Papua New Guinea and south of Honolulu, so we're sort of in between and right at the edge of what we call as coral triangle. That we have over 450 coral species, 1,500 species of fish, and we have probably some of the most intact coral reef systems that still remain globally, and why we are being very careful on development of aquaculture, as we've seen and we've heard from Robert and Julio on the potential impact of aquaculture on marine systems. Palau as a nation has about 20,000 local residents, so fairly a small developing island state. Prior to 2020, we had over 120,000 visitors, mainly visitors from Asia, who has appetite for seafood. And the main economy for Palau is tourism, and with the importance of tourism, Palau in the early 2000s established a protected areas network in hopes of ensuring that while we're promoting tourism, we are also managing our reef systems, which are important attractions for visitors. So on the environmental policy side, Palau has established over 30 coastal protected areas. And in 2015, Palau closed off 80% of its exclusive economic zone from commercial fishing. So that policy went into effect January 1st of 2020, leaving only 20% that is fished commercially. Next slide, please. So as a developing island state who has very much been influenced by Western cultures, Palau relies heavily on imported foods. So you can see on this slide a lot of canned meat. We also import chicken, beef, pork, and that sustains local population and tourism. So Palau ranks probably a third of them globally as the most obese people per capita. So this leads to a lot of non-communicable disease such as diabetes, heart attacks, and other non-communicable diseases that are prevalent within our local population. So focusing on food security for Palau is important, and mainly ensuring that there's healthy source of protein from fish that can sustain local population. Next slide, please. So why is it important to focus on developing aquaculture fish species to help sustain local source of fish protein. As we've seen globally, reefs are being impacted by climate change. So in 1998, Palau's coral reef experienced up to 98% bleaching events and reefs, and an average about 30% coral mortality. So these are widespread events that are becoming more prevalent, and dead reefs do not support a healthy fish population, and so that has the potential to impact food security for Palau. And as we continue to rely on fishing, next slide please. Palau have continued to overharvest the reef, leading to declining fisheries resources, which again pose long-term threat to Palau's food security. Palauans have begun to catch fish that are not mature enough to reproduce, leading to a lot of declining reef fisheries, particularly groupers and snappers. Herbivorous fish such as parkfish are also being targeted, as their preference for such species locally. And when Palau still allowed for export, there was also a lot of export of parked fish to nearby islands such as Guam and Saipan. Next slide, please. So in 2015, Palau began exploring hatchery production of rabbit fish, mainly two species of rabbit fish. The picture you see is Siganus linearis, and the other species that is being hatchery produced is Siganus fuscescens. These species were chosen because they have local preference within the local community, and also within the Asian visiting tourists. They also prefer this species, as it is also found within the Southeast Asian, particularly in Taiwan, where they've produced this in hatchery before. So we chose this species because we felt there's a local market. Any species that would be produced for export would be a bit unsustainable for local communities to farm, because the cost of transport and the cost of feeds outweighs the products that are produced, aquaculture products that are produced in Southeast Asia. And mainly the market that we would potentially garner for export for cultured fish would be the Asian market. And we can't really compete with fish produced within the Southeast Asian region. We import all the materials for developing the cages. All the feeds are imported. Even technical expertise gets imported to help with hatchery production. So cost of export of fish becomes very high. So we chose these two species to look at environmental as well as financial feasibility of farming these two species, both for sustainable livelihoods and then to address food security for Palauans. Next slide, please. So we have worked with the Palau government since 2016. The Palau government in 2010 established a Finfish hatchery with a partnership in partnership with Taiwan government. So Taiwan government sent expert to Palau, and they have about 5-year assignment here where they're focused on hatchery production, both research as well as production for farms. So they first started with a grouper, and they did release, which show that it was not financially sustainable to use that approach to try and improve wild stocks for groupers. And so they switched to rabbit fish. And as I mentioned, rabbit fish has shown a potential for local market. And so they started in 2016 mass production of 2 species of rabbit fish, as I said, Siganus fuscescens and Siganus linearis. Currently, the hatchery can produce roughly about 30,000 fingerlings annually. They're increasing hatchery space, and in 3 years, they'll have a target of about 60,000 fingerlings that can be produced within the hatchery. Next slide, please. We had worked with fishermen to try and transition them from fishing to farming the sea, particularly rabbit fish. There's this gentleman in green long shirt that you see is the owner of this Nabayama aquaculture farm, and he had focused on milkfish, but the fries are imported from Taiwan. So there's still a cost consideration for farming in Palau, as there's very limited hatchery space, and so we cannot be producing multiple species within the existing hatchery facilities. So we partner with farmers to try and encourage them to farm rabbit fish. So to date, there are about 9 active farmers whom we are working with to pilot farming rabbit fish, mainly looking at, as Julio showed some of the slides of rabbit fish that has deformity. Those are probably slides he took from the time he was in Palau, where the farms are experiencing deformity, and it may be due to location of where the farms are and the impact of water quality on the survival and growth and the health of rabbit fish. Next slide, please. So within this sort of pilot phase for the rabbit fish aquaculture in Palau, as Jonathan mentioned, we are working on siting analysis to identify the most suitable areas to farm these rabbit fish that will increase their growth and also minimize environmental impact. We're in the process of going through to collect field data to validate some of these areas that we've identified as priority areas. In addition, there is currently no aquaculture regulations in Palau, so it's considered a development. So whenever someone would like to establish a farm, they would simply apply for a water quality permit, and they consider it as development. So it goes through a very strict and rigorous requirements, such as development of environmental impact assessment and water quality monitoring and whatnot. So we hope that using this siting analysis, we can help to pre-identify areas that we can work with the government to develop regulation that can regulate and prioritize those areas that will make aquaculture much easier to acquire a permit than what it is now. And then also we're expanding our sustainable aquaculture approach to include the giant clam and giant clam Palau has already a 3-year experience with Chan clam. There's a dedicated Chan clam hatchery. We're trying to see how we can increase production to help support increasing farming that will help restock the reef as well as provide for food security and livelihood through ornamental trade of live Chan clams. We're also working with our government partner on exploration farming mangrove crab and expanding hatchery facility to be able to locally produce milkfish fries. Next slide, please. And that's the end of my presentation. Thank you. I'll turn it over back to Tiffany and Sherry. Thank you.
Thanks, Stephen, and everyone else for presenting the really interesting presentations. So now we're going to open the webinar up for discussion and questions. Remember, you can type your question into the question box, or you can raise your hand and we'll unmute you to ask your question. So go ahead and put your questions in the question box, and I'll turn it over to Tiffany to start asking questions. And I invite presenters to turn on your cameras.
Thanks, Sherry. We've already gotten some questions, which is great. So thanks so much to people that have been asking. But again, feel free to put more questions into the box or to raise your hand. So I'm just going to go down the list here. So we have a question here. Are commercial feed pellets available that use non-marine sources? So thinking along the lines of reducing impacts to harvesting from wild stocks that are used to produce feed for aquaculture. You know, is this maybe a question that Julio or Stephen may want to answer? Just know there was a feed trial that they conducted on this very topic.
Yeah, hello. So yes, there are a lot of feeds now being formulated specifically to use less meals and oils from fish that are being caught in the wild. As Tiffany mentioned, in 2019, I was in Palau to test different feeds that were formulated with plant-based proteins. So some were made with lentin, which is similar to duckweed, and some were made with soybean and soybean protein concentrate, and they actually performed better than the commercial feed that used fish meal. So there are commercial feeds out there that do have less, and if not no inclusion of fish meal. But that is what the industry is slowly going towards, is alleviating that pressure from wild stocks. Because I do agree with you, it doesn't make sense to catch fish from the wild to make food for fish that we're farming. It's not very sustainable. So yes, there is a lot of interest in alternative sources of protein and lipids for farmed fish.
Thanks.
Just maybe add a little bit on that. I think there's like some species of fish that are better candidates for marine-free diets than others. Like freshwater fishery, freshwater aquaculture, for example, really probably do not really require much fish meal or fish oil, but it is still used in a number of cases in low amounts. And that's getting towards more closer towards commercial production of fish meal and fish-free oil. We actually had fish-free feeds. We actually had participated in a competition, a challenge prize competition, to see who could produce the most fish without using fish meal. And a Chinese company was able to win that challenge with production of tilapia. Marine species in most cases are less good candidates for fish meal and fish oil replacements, but there's some exceptions. Like that's one of the really attractive things about rabbitfish is it's really a herbivorous fish, and we could create a feed that is fish meal or fish oil free. And currently the feed that had being used was more of a diet that was created for milkfish. It did include some fish meal and fish oil. We created this challenge with Julio, or this test with Julio and team to see how well that worked. In terms of like the mainstream production species, salmon, this has been like a major effort to move towards fish meal, fish oil free feeds. Probably on the fish oil replacement diets, we are closer along. Probably Veramaris is the company that's furthest along in commercial production of fish oil replacements. And some of that product is reaching market now, but it's not widespread yet. But there's been a lot of R&D going into this space, and it's really good to see that.
Thanks, Robert. We actually have we have a lot of people asking questions in the chat, which is great, but we'll go over to the person who has their hand raised right now. Sherry, would you be able to unmute Miguel?
Okay, so it looks like I can unmute Miguel, but I think Miguel also has to unmute on the other side as well.
Okay. Give him a few seconds, see if we can figure that out. If not, we'll go on to the next question. Maybe message him directly as to if he's able to unmute. All right, well, we'll give him some time to figure out how to unmute him, and we'll go down to the next question. So what made you choose these two species? And this is directed towards Stephen. Did you test others? What are the commercial size of the fish? And how many tons are you in capacity in terms of producing? Stephen.
So thanks for the question. And the species were chosen based on local preference for route fish here in Palau. As I've mentioned, the Palau National Aquaculture has tested the grouper before, but mainly they did wild release rather than farming because of the cost of farming, and so they weren't encouraging farming grouper. The wild release, they didn't do proper monitoring to see how successful it was, and by all indication, it wasn't as successful as hoped because the fingerlings were released at a very small size, so they probably were eaten. To keep them in the hatchery for size that when they released increased survival would add onto the cost of operating the facility, and that's why they chose to release them at a very small size. Currently, as I've mentioned, there are 9 active farmers farming rabbit fish with an average of 2 cages. So there's not enough rice to provide to the fishermen on a basis where once they harvest, they get price replenished. So it's cage can hold up to 2,000 fish, and the harvest rate is around 300 pounds of fish per cage. And so it's still at a very initial stage of exploration, and as Julio showed the picture, there's still a lot of disease and deformity in these fish, and it's primarily due to where they're being farmed. And so we're hoping that we can use the sighting analysis to then further test cages up to 10 within a site to see how what's the feasibility of producing more fish at a lower cost. Thank you.
Thanks, Stephen. All right, we're going to go on to the next question. Great presentations. Thank you all so much. How do you protect these farms from intense storms like hurricanes? Do we have anyone who wants to field that question?
So let me start, and then I think Jonathan has, through the sighting analysis. So primarily, one of the reasons why the farms are located where they are now is to try and avoid damage from high winds. And as you look at the design of the cages, they're made from 2x4s, and so they're simply screwed and nailed, and so they're not as hardy as materials that we would order from manufacturer, let's say in China. And so the current cage materials are not enough to withstand strong waves and high wind, and therefore they're located where they're located are currently located to avoid that. And let me give it to Jonathan to answer it based on the analysis. Jonathan?
Sure. So when we think about siting analysis, in the example in Palau, we actually ran a wave model to help identify where there would be stronger wave action. But one way to avoid things like hurricanes is you would pick the leeward side, or the less wind-driven side of the island that has more protection. Another option is actually moving the cages closer to shore during this type of event. So there are different options for avoiding really strong weather like hurricanes.
Thanks. That's actually the next question, maybe for you, Jonathan, as well. Which parameters, currents, wind depth, bottom type productivity, are the most relevant in terms of siting for mariculture of fish? So maybe this is for you, Robert. Anyone else who wants to take this?
Sure. So there's, for the Palau example, we started off with our own bathymetry layer. So we got our depth profile, and that was a really important layer to have. Not only does it show the bottom depths, but it also helps identify areas that may have coral as well. So where you have shallower areas you want to avoid. Currents, waves are very important as well. Currents, I would say, almost more so than waves. Waves you kind of want to avoid. Currents you actually need. So you need to have some currents in the area to help flush the area, ensure that there's enough dissolved oxygen for those. So those, I would say, currents would be more important than the wave.
Anyone else? Otherwise, we can go on to the next question. All right, and we do have a question from Miguel. He's able to type it in. Sorry, we couldn't hear him before. This is Miguel's question. We know that most of aquaculture species in the tropics are brackish water species. Like rabbitfish, for them to optimize their growth, they need to be in areas affected by mixing of fresh water. So to grow them in deeper water that is 100% oceanic water may affect this growth. How can we address this consideration? Is there an effect that ocean water, non-brackish water, is going to have on rabbitfish? Maybe is that something that's going to affect their growth?
It's a really good question, which I don't have an answer to at the moment. And part of this pilot, we could probably look at. Well, we had a farm up in the North Island where the impact of salinity didn't fluctuate because it's on an atoll. So, and it's hard to say whether it was the feeding that had affected the growth or the salinity. So we've grown the species within areas that sees less fluctuation in salinity, and they did grow, but it was hard to determine whether it was there was an impact of salinity because the feeding wasn't always consistent. So we look into that. Thank you.
I wanted to quickly add to that, and I do believe there is an impact on growth if you go from a fish like rabbitfish that naturally lives in brackish water and you put them in 100% marine water, there has to be some kind of physiological process that makes it harder for the fish to osmoregulate. If it's in a full marine environment, it might have a harder time to do so. But that's why it's very important to, once a species has been selected and that is the species you want to farm, it's then important to go through the site selection process and using all these different GIS tools to figure out where's the most ideal location that ideally has a mix of fresh and water. But I think it's a very good question, because yes, we want to move further away from the coast because it can, you know, impact the coastal waters, but at the same time, it's kind of a give or take situation. But I think it's a very good question.
Yeah, I think this like brings up like a more general principle around, you know, on one hand, you have like an environmental consideration around depth and current, which is generally not always found farther from the coast, versus a productivity factor, which Miguel is implying, you know, salinity, which may be closer to the coast, is better for the species. Now, those are kind of maybe coming into conflict or dramatically narrow the sites in which this may be present. So like the first thing, as Julio had said, is like, can we find some sites that do meet the intersection of both? But I think the thing that we do not want to be doing is compromise our environmental values for the sake of production. That would not be what we would want to go forward and do.
Thanks, guys. Yeah, that's a good question. I have a question here for Jonathan. You spoke about mathematical models and weighting of variables to predict the best sighting locations. Can you speak to the process, if there is one, to evaluate a location and validate your model once a farm is located to measure the impact the farm has and what adjustments might be needed to the sighting models going forward?
Yeah, so just talking a little bit more about the model. So we use a multi-criteria decision analysis. We don't weight individual variables. We give them all equal weighting. And we use a 3-system scoring where we use 0 for incompatible, 0.5 for areas that may be compatible but not 100% compatible, and then 1 for most compatible. And then with that result, if a farm is chosen, you can actually do one more step before then. You can run what's known as a carrying capacity model that looks at, you know, the influence of nutrients in that area with multiple farms. So there's one more step that you can do before that. But then once the farm is sited, then it relies more on the monitoring process that's in place that Julio spoke about. So once the farm is in place, then monitoring takes over to, I guess, evaluate the success of that farm and ensure that there's no effect on the environment surrounding the farm. So it becomes less of a suitability model approach, and then once the farm's established, it's strictly just on monitoring and planning that was done beforehand.
Thanks, Jonathan. All right, on to the next question. So it's good day. At my workplace, we've been utilizing tilapia in an aquaponics system. My question is, what can be done to prevent the stock from breeding in the tanks? Does anybody want to grab this guy?
I think with that one, you would want to try your best to remove males and females. I think once you have a tank with males and females and they reach the point of sexual maturity, then they're going to start breeding and get aggressive towards each other. I know with aquaponics, and specifically tilapia, you can treat the fish when they're larvae to have them all be male. So then you have an all male culture. But if you don't have access, it's a chemical that you need to be approved and all that. But I think best option will be to separate males and females once you can determine their sex, and then that would potentially reduce them for reproducing in the tanks.
Thanks, Julio. All right, we have a question here about cages. Do you have any more information on the characteristics of the cages and how to assemble them? And I know that on the toolkit, we do have a little bit more information about cages themselves. I do not believe we have any instructions on how to assemble them. Is this something that anyone would be able to speak to or provide a resource?
So for the cages we're using in Palau, they were assembled by our government partners. They're simply 2x4s that are put together on top of floaters. The main challenge is getting the appropriate netting for the cage, which is not available locally, as well as the floats. It took several trials for the government staff to get the cage materials and the design to what is appropriate for the location. So I know there are cage materials that you can order from manufacturers, and they would come with instructions on how to assemble them. But the materials, the design we used in Palau is more of our own design that we established. So,
thanks, Stephen. We have a question here. Do any of the parasites of fish, of the farm fish, have the ability to or transfer to the human food chain? Is there anybody that wants to grab this question about the potential of parasites that Julio talked about in terms of ensuring good monitoring to try to prevent the parasites? Is there the potential of that transferring into the human food chain?
So most of the parasites we're talking about are ectoparasites, like sea lice or gill flukes or other things like that. And those are really like through the processing and filleting and cooking of the fish. I don't believe they really pose any substantial human health issues. Now, there are parasite issues associated with eating seafood and some mostly wild fish, worms in the flesh of the fish. This is a particular concern with a lot of freshwater fish, but some saltwater fish as well. The yellowtail kingfishes, the codfish are known to have those kind of worms. They're usually not harmful if cooked, but they could be transferred into a human host.
CDC and FDA.
And but when we aquaculture those same species, generally the fish don't actually have those worms in the fillets and meat themselves.
And this is kind of a related question. We'll keep on this line. It says, currently there's a limited variety of therapeutics available to fish in comparison to other farmed land-based animals. Is TNC supporting, investing, or encouraging research to grow the availability of medications to keep fish healthy and reduce disease exposure in open water environments?
Well, fish welfare is really important, right? I think no one here would say that we should be growing fish in a way that's not respecting those animals. And for treating the health of the animal, sometimes it is appropriate to use antibiotics. And the suite of antibiotics in some country, or antibiotics that are available in some countries, is limited, such as the United States. Those animal drugs, there's a reason to advance them, but they need to be used responsibly. So there are really well documented evidence of abuses of antibiotics in the aquaculture industry in places around the world. We know that because FDA does sample products for trace residues of antibiotics, and they trigger import alerts from those countries. So abuse of antibiotics and abuse of animal health treatments is something we're absolutely not in support of.
Thanks. I have a question here about multi-trophic aquaculture. So what about multi-trophic aquaculture? Do you think that this could be good for coral reef areas? Is there anyone who'd like to talk about multi-trophic and just whether or not that's a strategy that could be employed in coral reef areas?
Yeah, we sort of considered that, especially for rabbit fish that are being grown in areas like this of growing, let's say, sea cucumber or giant clams. We haven't quite gone that far to test the feasibility of doing that, but we think that it's good idea to explore. We just haven't been able to get to that level of experiment where we're doing that.
Thanks, Stephen. I've had a couple questions come in that are asking whether or not the recording is going to be available and whether or not we have PDFs of the PowerPoint. And I just wanted to say to everybody, yes, we will make this recording available. And we can also have the PDF available of the PowerPoint. However, the toolkit is also now online. And so there are a lot of downloadable resources directly on the toolkit too as a resource. So just wanted to pause and say that real quick. And I think we actually may be to the end of our questions. Let me see if there's anybody else that's raised their hand. If there's anybody else that has a question, it's really well timed because it's 8:26, and I know that we need a minute or two before to close. But I guess I'm going to do a bit of a last call, see if anybody has any last questions. And thank you to everybody for your really, really great questions. These are really important questions to ask, and we appreciate them. All right, I'm not seeing any other questions. Sherry? Oh, wait, hold on. We've got one from Christopher May, just under the line, under the wire. Do we have enough time, Sherry?
Sure.
All right. If you want to unmute Christopher.
Okay, hold on one second. Is that a hand up or just the question?
I'm seeing a hand, but oh, the hand's down. Okay, all right. Then I think that we have had all the questions, which again, everybody.
Great. Okay, yes. Well, thanks again, everyone, for joining us and for the great discussion. It looks like we got to all of our questions, Tiffany, today.
I think so.
That's
we have, I think so. We have one question from Christopher that he just typed in. So, has parrotfish been considered for mariculture? So, if anyone has any experience with parrotfish, that is our last question.
Julio, Dan ever try to culture parrotfish? I'm not aware of anyone trying to culture parrotfish. It must be a pretty hard species to work with. Also, probably not a particularly interesting fish for food, but you could probably see the interest there in aquarium species.
Oh, Julio, you're muted.
Yeah, as far as I know, there isn't too much, technology or commercial interest in parrotfish. I do see that they have a value in terms for the coral reefs as the overall health, but when we're looking more at the commercial side, there doesn't seem to be too much push for the species.
Okay, thanks, guys.
Great. Well, yeah, great. Well, with that, we'll go ahead and wrap up. And I just wanted to put a couple links up here. So we have the link to the Aquaculture Toolkit. So please go check it out. We hope it's useful to you in your work. And also, there is a post about this webinar on the Reef Resilience Network forum. So if you're interested in continuing the discussion, please go there and find that post and you can start the discussion there. So thanks to everyone and have a great day.